With the addition of UnrealReader to the NukeX toolset, Nuke users can tap into the rendering power of Unreal and streamline their workflow without ever leaving their compositing application. In this short tutorial, we will have a look at the way you can use NukeX to easily augment any render coming from Unreal and add or alter any elements that might need additional work. To capture our output from Unreal to Nuke, we require a few prerequisites, namely Unreal Engine running on a local or remote machine, the Nuke server plugin installed within Unreal, instructions on how to do so can be found in our documentation, and access to NukeX 13.1 or higher. Also, if you would like to follow along, we will be using the Subway Sequencer project available for download from Epic. We'll start by opening the project we'd like to work on within the Unreal Engine. Once the project opens, we can confirm that the bridge between Nuke and Unreal is up and running. The order of actions here is not important. What matters is that Nuke and Unreal can communicate with each other. To do so, let's go to Windows and find the Nuke server entry. Click on that and the server window will pop up. Start the Nuke server from here. And now we are ready on the Unreal side, we can return to our Nuke session. Once in the Nuke session, the first node that we'll need to create is the UnrealReader node. This tool facilitates the connection to the Unreal Engine, and it will allow us to harvest the output coming from Unreal. With the UnrealReader in our script, the connection to a locally running instance of the Unreal Engine will be established automatically. Or alternatively, we can connect to a remote machine running Unreal. In this case, Unreal is already running in the background, so we are good to move forward. Once the handshake is successful, we'll see the first set of pixels appearing in Nuke. As a next step, we'd need to choose a map from our currently open Unreal project and a shot to work with. In this case, we'll select shot number 170. Once we have our shot selected, we can go ahead and start thinking about render passes that will be needed to successfully execute our image alteration from the list of passes available in Unreal. Since we are replacing a part of an existing element in the shot, we'll need a way to align our new Nuke-created objects to the objects already present in the scene. To help with this, we'll need the world position pass that Unreal Engine provides. Next, we'll need to be able to isolate and mask the objects in the scene, since the foreground characters will partially obscure our composited-in element. Cryptomatte pass coming in from Unreal should cover most of our needs, so let's go ahead and select that one. It's worth noting that aside from Cryptomatte, we can also use the stencil layers approach to isolate rendered elements in an Unreal Reader, but for this example, the Cryptomatte will be more than sufficient. Let's also enable the scene depth pass for post depth of field effect. Once we're happy with our selection, we can confirm that the selected passes are being received by Nuke by pressing the Update Channel List button, and we can see them in the channel list. We can optimize our workflow further by pre-rendering the images to disk to avoid unnecessary communication between Nuke and Unreal. Just remember that new passes can be added at any point if needed. Let's go ahead and render out our scene, and once done, let's enable read images directly from our UnrealReader node. Now that we have our prep work done, let's create a 3D reference representation of our scene so we can place our new element accurately. Let's start by shuffling out the world position and the RGB layers. Once done, we can create the Position to Points node and connect our new shuffle nodes to their respective slots. This combination will provide us with an accurate 3D representation of the Unreal scene in Nuke's 3D viewport. Let's go ahead and create a card that will represent our new element and align it to the reference points in the scene. Once done, we can create a scene node followed by a scanline render node and connect them all in succession. To match the motion of our new Nuke-generated element and the Unreal scene, we will also need a camera that is matching the animated shot camera from Unreal. Luckily, the Unreal Reader can easily generate one for us. Let's return to the Camera tab under the Unreal Reader and click Create a Camera, leaving the rest of the settings on default. With the camera created, let's connect the new matching camera to the cam input of the scanline render node. Now let's merge the output coming from the scanline render with our main stream coming from Unreal, and let's have a look at our progress so far. As you can see, first we will need to mask the rendered card with our foreground characters. Let's go ahead and create the Cryptomatte node and use the Unreal stream as the input. We will be presented with a visual representation of all the available elements in the Cryptomatte pass. We can use the Picker tool to select the elements we would like to generate masks for, or we can use wildcards to select all the elements that share common naming patterns. With our mask created, we can now use it as the mask input on our merge node and then invert its effect. As you can see, our card appears now correctly ordered behind the foreground elements, but its shape is still not matching the rounded shape of the screen we're placing it into. And in this case, the Cryptomatte pass won't help us either, since it doesn't contain the screen as a separate element. To remedy this, we can use Nuke's 3D projection system to quickly make a matching roto shape and project it onto our 3D card. Let's start by creating a roto paint node followed by a project 3D node. For the Project 3D camera input, we can use our Unreal Shot Cam, frozen on a frame where the element is fully exposed and clearly defined. In this case, let's use the first frame. Now let's connect the output from Unreal to the background input of our roto shape to get the proportions and placement correct for our mask. And let's go ahead and trace the element we would like to isolate. Once we're happy with the roto shape, we can check to replace the channels checkbox on our roto node to remove the background pixels we used as reference. Let's have a look at our result now. As you can see, our projected mask now works quite well. To add our new element that goes into the screen, let's duplicate our 3D setup. Bring in any footage you would like to use in the screen and replace the existing connection. Copy our projected mask as an alpha to the render of our new element and add a few beautification final touches. With the addition of an Unreal Reader, the Unreal Engine can become a powerful extension of Nuke's built-in toolset. There you have it. We hope you enjoyed this tutorial and happy compositing.